Myself, Sainora B. We are going to discuss about the topic design and analysis of parallel algorithm. So, designing and analyzing parallel algorithms involves creating algorithms which can be executed simultaneously on multiple processors to solve problems which are faster than on a single processor. The key aspects of designing and analyzing parallel algorithms it include identifying parallelism, managing data dependency, balancing the load among processors, and minimizing the communication overhead. So, designing and analyzing parallel algorithm involves several key steps and considerations to ensure that algorithms are efficient, scalable, and correctly utilize the available processors. First one is problem decomposition. Here it breaks down the problem into smaller tasks that can be executed concurrently and partition the data into chunks that can be processed in parallel. So this aim to maximize independent tasks and minimize dependencies. Next is identify parallelism. So this step determine which parts of the algorithm can be executed in parallel, which looks for opportunities in loops, recursive structures, or independent tasks. Next is task scheduling and load balancing. Here I distribute tasks evenly across processors to avoid idle times. There are two types of scheduling, static and dynamic. Static means pre-assigned task to processors before execution, and dynamic means it assigns tasks to processors at runtime which can handle irregular workloads more efficiently. Next step is minimize communication and synchronization overhead. So it ensures processors work on data close to them to reduce communication time. It uses efficient synchronization mechanisms like barriers, locks, and atomic operations. Next is algorithm design. It uses the Pram model to guide the design. Consider the target parallel architecture. So next is parallel random access machine, which is a theoretical framework model used to design and analyze parallel algorithms. It provides a simplified abstraction of a parallel computer where multiple processors operate synchronously and access a shared memory with no latency. It helps in understanding the fundamental aspects of parallel computation like concurrency, synchronization, and communication. So, this is a pictorial representation. Here, multiple processors that execute instructions in parallel are processors. Then shared memory, which is a global memory accessible by all processors. Processors operate in lockstep, which means that they execute instructions synchronously. And a memory access model, which defines how processors read from and write to the shared memory. So, as I told, parallel random access machine models are theoretical models which are used to design and analyze parallel algorithms. These models differ based on how they handle concurrent read and write operations to shared memory. So these are the four main types of PRAM models, which are exclusive write, exclusive read, concurrent write, and concurrent read, exclusive write, and concurrent read, concurrent write. So first one is exclusive read, exclusive write. So it means that no two processors can read from the same memory location simultaneously, and no two processors can write to the same memory location simultaneously. Next is exclusive read, concurrent write. Here, no two processors can read from the same memory location simultaneously, but multiple processors can write to the same memory location simultaneously. That means concurrent write. They can write to the same, multiple processors can write to same memory location. Next is concurrent read, exclusive write. It means concurrent means multiple processors can read from same memory location simultaneously. Then no two processors can write to the same memory location simultaneously. Next, concurrent read, concurrent write. It means multiple processors can read from the same memory location simultaneously, and multiple processors can write to the same memory location simultaneously. So this is the most flexible and powerful PRAM model, but it requires several mechanisms to handle concurrent writes like common CRCW, arbitrary CRCW, priority CRCW, and random CRCW. So common CRCW means all processors attempts to write to the same location must write the same value. Next is arbitrary CRCW. Here one of the processors is allowed to write which is chosen arbitrarily. Next, priority CRCW. It means processors have priorities and the processor with the highest priority writes. Next, random CRCW. It means one of the processors is chosen at random to write. So these are the models. Mm, These four are the models which helps in understanding the complexities and then potential difference or potential performance of parallel algorithms under conditions. Conditions are about the memory access. So each model provides a different balance between the complexity, power. So this makes them suitable for different types of parallel computation problems. Next is handling read and write conflicts in these models. So handling read and write conflicts in parallel computing is a crucial step because it ensures the correctness and efficiency of parallel algorithms. So, different Pram models address these conflicts with varying strategies. So, read conflicts means it occurs when multiple processors attempt to read from same memory location simultaneously. So, these are simpler to manage compared to write conflicts. The exclusive read exclusive write model disallows any simultaneous reads from the same memory location. So it ensures exclusive access, while the CREW, that is concurrent read exclusive write model, it permits concurrent reads which allows multiple processors to read the same data without conflict. So this makes the CREW more flexible and often more efficient for read heavy algorithms. Next is write conflicts. So this write conflicts occurs when multiple processors attempt to write to the same memory location simultaneously. So these are more challenging due to the potential for inconsistent data states. The EREW and CREW models prohibit simultaneous writes to same location. This requires algorithms to ensure exclusive writes, often through task scheduling or additional synchronization. In contrast, the concurrent read, concurrent write model allows concurrent writes, but it needs mechanisms to resolve conflict. Subtypes of CRCW handle these conflicts differently. As we can say, common CRCW require all processors to write the same value. Arbitrary CRCW arbitrary selects one processor's write to succeed. In case of priority CRCW, it uses a priority system to determine which write occurs, and in random CRCW, it randomly selects a write to succeed. So, these are the practical techniques for handling write conflicts in any of these models, like locking mechanism, atomic operations, barriers and synchronization, then software techniques, and communication. So, in locking mechanism, it uses locks to control access to shared memory location, ensuring exclusive access. In atomic operation, it uses atomic instructions like compare and swap or fetch and add to perform operations atomically, which ensures that only one processor can perform the operation at a time. Using barriers and synchronization, it synchronizes all processors at certain points to ensure that certain phases of the algorithm do not overlap, and it uses semaphores to access to shared resources. Next is software techniques. Uh, it uses two buffers to separate reading and writing phase, ensuring no overlap, and use version numbers to manage concurrent access, allowing processors to read consistent versions of data. And in communication, it minimizes the need for communication between processors by designing algorithms that reduce shared memory access, and by using message passing technique instead of shared memory when possible, especially in distributed system. So overall, the choice of conflict handling strategy depends on specific Pram model and the nature of the algorithm. So by carefully selecting and implementing these strategies, the parallel algorithms can efficiently manage read and write conflicts. So work efficiency. So in parallel algorithms, work efficiency means how or measures how efficiently computational resources are utilized relative to the algorithm's performance gains. So defined as the ratio of the speed up achieved by a parallel algorithm to the number of processors used. So mathematically it can be expressed as efficiency E is expressed as E of P equal to S of P by P, where the S of P is the speed up obtained with P processors and P is the number of processors. So for an algorithm to be efficient, the overhead caused by parallelization communication uh, must be minimized. So this parallel algorithm's efficiency is closely linked to its total work and parallel time. So total work means it is the cumulative amount of computational effort performed by all processors, which is ideally equal to work done by the best sequential algorithm. Parallel time is represented as this, and it is the time taken to complete the task using P processors. So according to Brent'S theorem, the parallel time is bounded by T of P less than or equal to W by P plus D, where D is the depth of the computation representing the longest sequence of dependent steps. So we can say that in summary, work efficiency is a crucial metric in parallel algorithm design. It indicates how well the parallelization leverages multiple processors. So an efficient parallel algorithm performs close to the theoretical optimal. It maximizes speed up with minimal additional overhead, thereby utilizing computational resources effectively. Thank you.